Alright guys, welcome to this set of videos, and what we're going to do here in these videos is they're going to follow along with the notes that come out of your guys' textbook from Chapter 3, Section 7. Now, when we first started this second half of Chapter 3, I mentioned to you that it might seem like it's kind of coming out of left field. We had just been doing systems of equations. Why now all of a sudden are we doing these things known as matrices? Where is this coming from? And I mentioned to you at that point that eventually we were going to get to something where we would be using matrices to help us solve systems of equations. And that's what we are now going to get to here in Chapter 3, Section 7. This section is going to be all about using the determinants of a matrix, and something known as Cramer's rule to help us solve these systems of equations. So let's go ahead and get you a couple of objectives or learning targets. We'll jump right into how this stuff works. So a couple of things that you guys should be able to do by the time we get to the end of these videos, the end of this note set. You'll need to be able to evaluate determinants. I'm going to have you evaluate two kinds of determinants. You'll be able to evaluate a 2x2 square matrix, the determinants for a 2x2 square matrix, and the determinant for a 3x3 square matrix. That's as big as we're going to go in this class, so you should be able to do both of those kinds of matrices. And then the last one, once we know how to find these determinants, we're then going to learn Cramer's rule and use it to solve systems of equations. So let's go ahead and jump straight into this. A little bit of notation for you guys, and it is this. You know what a matrix looks like by now. We've done several sections on matrices. The determinant. What it's going to look like is it's going to be a matrix, the typical array that you would have, whether it be constants or variables, whatever, but it's going to be inside of what looks like absolute value signs. However, we're not going to be taking the absolute value. We're going to be finding a determinant. I could also write it like this. If I wanted you to find the determinant, I would simply abbreviate it DET, so determinant, and then give you some sort of matrix that I want you to find the determinant of. This means the exact same thing, find the determinant of this matrix. Or I just put that determinant in those absolute value signs, and you will be finding a determinant. Now, how do we go about finding the determinant of a 2x2 square matrix? We're going to start off with the simplest case. So you're given this 2x2 square matrix, A, B, C, and D. Now, here's the way that it works. What you're going to need to do is you're going to need to find the product of the major diagonal. So that's going to be these guys right here, A times D. A times D. You're then going to need to find the product of the minor diagonal, which is going to be C times B or B times C, whichever way you want to write it. Remember, multiplication is commutative, so it doesn't matter. I'm sorry, I wrote those in the wrong order. That's not a B. There's a B. So you will find A times D, you'll find C times B or B times C, whichever. And now what you're going to do is you're going to find the difference between A times D and C times B. It'll look like this. You would do A times D, right? Whatever that number comes out to be. And you're going to subtract from that C times B. Now, the way that you could think of this is you take the major diagonal, A times D, call that the bottom number, right? Because that's going to be my number down here. You take the product of the minor diagonal, C times B, you're going to get this top number up here. So a nice way to remember the way the subtraction works is it's going to be the bottom minus the top number. Bottom minus the top number. And that's exactly what I have written for you here. Again, both ways, determinant of the matrix, or I could write that matrix inside of what looks like absolute value signs. Just remember, it means find the determinant. And this is how you do it, right? I take A times D, there it is, subtract from it C times B, or B times C. Again, it's multiplication, commutative, doesn't matter what order you do it in. And that's it. That's how you find a second order determinant. So let's go ahead and try some of these. I've got a few examples for you here on the next page. Feel free to work ahead on these and then come on back and check your answers with me. Make sure that you've done it correctly. So let's just jump right into this. Remember now the way it works, I'm finding the determinant because it looks like absolute value signs of a 2 by 2 matrix. Major diagonal, 2 times 3 is going to be 6. So this is equal to 6. And then I'm going to subtract my minor diagonal, 0 times a negative 1, which would be 0. 6 minus 0 is 6. It's just that simple. I got a couple more for us here. Let's run right down through these and see how they go. Determinant, because it is looks like absolute value sign, so I need to do 5 times 9, which of course is going to be 45. I'm going to subtract from that. Oh, careful. Watch your minus signs here. I'm going to subtract, and then I have a negative 4 times 8, which is going to be a minus number. In fact, it's going to be a negative 32, so minus 32. Be careful of your signs here. You'll need to add the opposite, and you wind up with 77. Fantastic. Let's keep going. A couple more. This one I've written both ways, right? So I've given you the matrix A. This is our matrix. And then I want you to find the determinant of that matrix. Again, doesn't matter which way I give it to you, whether I put that matrix in absolute value signs. It doesn't mean absolute value. You now know it means find the determinant. Or I just write DET, right? The abbreviation for determinant. You're finding a determinant. So here we go. The major diagonal, negative 6 times 8 is going to be a negative number. So we have minus 48. We're going to subtract from that my minor diagonal, 10 times a negative 7, which would be minus 70. I'll put it in parentheses so I don't get my negative signs messed up. And we add the opposite, so I'm going to wind up with a negative 48 plus 70. Hopefully you get 22 like I do. I got one last one here before we try something else. Again, what I've done is find the determinant. I didn't even abbreviate it in this case. I just tell you find the determinant, and then I give you a matrix. No problem. 7 times a negative 4 is going to be a minus 28. We're going to subtract from that 9 times 5, which again is 45. So I have a negative 28 minus 45. We will, right, subtraction, so add a line, change the sign, minus 28 plus a negative 45. I get minus 73. All right, guys, that's good work. Hopefully that makes sense as far as finding the determinant of a 2 by 2 matrix. Head on over to the next page of the notes, and we'll take a look at how you find the determinant of a 3 by 3 matrix. So I'll meet you over there.